All right, part two. Sorry that took so much explanation on that first half. We haven't really even done any problems yet, but it's almost a lot easier in class to show you where the slant height is on a pyramid or on a cone because you can hold the object in your hand and I can point to things. So make sure you get a good idea of where the slant height is on an actual 3D object before you go to try to compute these things because it's incredibly important to have the height and the slant height figured out differently and realize that you can get one from the other if you know the apothem with this right triangle in here with Pythagorean theorem. Okay, so let's actually do some. Now here, this was kind of mean. They didn't draw that very triangle. They drew DE in there, which DE is the slant height, which is nice. And that's L, and of course they drew it next to this other blue one that looks like it's a lateral edge. Well, they're labeling it as ED, so be careful of that. Remember the triangle we cared about had an H and an A and an L in it. That was kind of helpful. But this triangle, it's a triangle. They drew this red segment down here. That's not the apothem, that's apothem. This is the distance from the center to the edge. I don't care about that nearly as much as I care about this one, which just makes it harder to see. That's A. This is L. The height that I'm probably going to want to talk about is there, which again, it's hard to draw because there's all this other junk in the way. So you really have to think about this in terms of a 3D picture. Okay, we want lateral area. Lateral area was half times P times L. You might see me say LP just because our last book did LP and this book does PL. You might see LP on Wikipedia or Khan Academy or something. And surface area is going to be lateral area plus that pentagon base. All right, so let's do lateral area first. Half times perimeter of the base. Ooh, perimeter of the base isn't going to be bad. Perimeter of the base is 8 times 5. That's the perimeter of the base because that's a regular pentagon. And each side is 8. That's great. And the slant height, oh, I know that. That's 11. Okay, this isn't so bad. This, I kind of have everything I need. That's great. The hard part is, I think, going to be area of the base. Half times 8 times 5 times 11 is not pretty. That's half times 8 times 5 is 20. 20 times 11, I can almost do this in my head. This is 220. I believe you could do that in the calculator probably faster than that. And then, so that's part A. Part B is, let's take that lateral area and let's add a base to it. So this is going to be 220, which I just did, plus the area of this base, which is half AP. Now, honestly, I'm not sure that a regular pentagon could have a length here of 5 and a length here of 8. That may actually be impossible, but for now, we're going to go with that. If you saw this on the test, you'd have to believe it, so we're just going to do that. Maybe forget I said that. We'll just go with what's printed. That's the safe way out. Anyway, half times, I was doing okay until I got here, apothem. All right, that's this thing in here, this little apothem here. I almost want to draw a new pentagon and think about that for a second and think, okay, if this thing is 5, that's good, that's really small. What's this? Well, this little angle in here, that has to be, okay, draw that little triangle bigger. If that distance was 5 and this was what's that little angle here that's at the center of the pentagon? If you remember from all that pentagon work we did recently, that's 36 degrees. That is 360 divided by 10. So if this thing is 5, what's this? I find that out to be with the cosine of 36. The cosine of 36 equals adjacent over hypotenuse. And this is what I'm worried about. If you did that with this side down here that has to be 4, you'd figure out that A has to be 3, and I don't know that, Pythagorean theorem even, and I don't know that you'd get that with the cosine of 36. Or if you figured that out with a 4, and then you did something like tangent of 36 with the A and the 4, you might not get the same answer. I'm going to go with the 5, because I haven't used the 5 for anything else, and I think it's probably close anyway. So 5 times the cosine of 36 is what A is. So that's what I wanted. I wanted A here. 5 times the cosine of 36. And then I have to take that times P. And the P I already did. It's 40, because it's 5 of these 8s around the whole thing. Okay, calculator time. Half times 5 times cosine 36 times 40. Let's just go straight to decimal. That's 80.90. Oh, come on. Sorry, excellent page. This is 80.9. This is 220. Now we're in approximately equal land. That works out to slick 300.9. Okay. Given the regular square pyramid with bases 10 and lateral edge of 13. All right, lateral edge is, well, if you had this thing physically in your hand, lateral edge is something that's easy to measure. But notice how lateral edge never shows up in any of the formulas. Lateral edge is not completely useless. So, I mean, you think about that. If that lateral edge is 13, this lateral edge is 13. On the face of it, this is a right triangle. There's a right angle here between slant height and the base edge. It's kind of leaning back. It's like actually on the face of the mountain. I have a right triangle with the hypotenuse is 13. The leg is slant height, and this part down here would have to be half of a side of the base. Like if this is 10, these guys have to be 5. So I have a triangle here with the 5. There's a lot of right triangles in here, so pay attention. This is a 5. This is the slant height, and this is 13. If you do this with Pythagorean theorem, you find out 5 squared plus L squared. This is one of those triples you're supposed to know. This turns out to be exactly 12. That's a 13 squared. That's a 13 squared. L is going to have to be 12 here. So they did this so that 12 turns out to be nice. Or L turns out to be a nice number. Oh, that's right here. That's 12. Axis altitude, that would be height, we call that in most people's terms. They call that height. All right, the slant height is 12. The HAL triangle looks like this. There's another triangle down here with the L along a hypotenuse. Now, I know you're saying, now, wait a second. A minute ago, L was a leg. Well, yeah, that's 2 different triangles. There's a right triangle. Maybe this will make it easy to see. There's a right triangle here that we just dealt with. It was on the face of the pyramid. There's a right triangle here. And this is, like, if you're trying to paint the outside of this pyramid, you'd actually be able to paint that pyramid. Then there's another right triangle that's hanging like a curtain, like a half curtain on the inside of this. Like if we were in a tent here, this would be hanging inside the tent. It's a totally different triangle. In the yellow triangle, this would be the yellow triangle. And before we were dealing with that orange triangle, and they're totally different triangles in this thing. Can you still read all my numbers? Yeah. So in that triangle, in the yellow triangle now, L is now the hypotenuse. Apothem down here is apothem down here at the bottom, and that, if this is a square, that's just 5. So that's not tricky to figure out. And height is what we're looking for. So now we do that one again. H squared plus 5 squared. This one's not going to be pretty. Equals 12 squared. That's going to be 144 minus 25. H is going to be the square root of, what's 144 minus 25? I can do square roots in my head, but I can't subtract. 119. All right. So this is the, oh, where's my pen? This is the square root of 119. Okay, and that's what we wanted here. It's almost 11. Whoops, 119. I said 11 and I wrote down a 2. All right, square root of 119. And then lateral area. Well, that was half times the perimeter times the slant height, which is half times the perimeter. Well, this is a square and it's got side of 10, so that's just 40. Times the L, which is that thing right there. So you could call that 20 times the square root of 119, or you could decimalize that. Notice how we always accept either decimals or exact answers. Sometimes in this video I'm doing exact answers, sometimes I'm doing decimals to illustrate that fact. If you want to know the conversion on any of them, comment in the space below and I will answer your comments. Okay, given the cone on the diagram, find lateral area. Well, lateral area was half, remember I said you could call it half PL, or if you wanted to memorize a new formula or look on the sheet for a new formula, if you have the time to do that, you'll figure out that it's pi RL. Either way is the same. Since we haven't done pi RL yet today, I'll go ahead and use the pi RL formula. There's nothing wrong with that. Pi RL, because they're kind of right there ready to go, that's pi times the radius, and here we mean radius of the base, and the slant height, L, is this thing here, and we have a right triangle all here ready to go. I think cones are a lot easier to see, that little right triangle, than it was to see that right triangle business here with that yellow thing. Here is really not much to think about. So that's just simply 3 squared plus 10 squared is going to equal that thing squared. So L is going to be, that's 100, that's 9. It's the square root of 109. And really, that's, you can't really simplify that anymore. It's 109 3 times square root of 9 times pi. So I'm just going to kind of leave it like that. I don't think there's any better way to write that. Maybe rearrange the 3 and the pi. Not worth my time. Surface area is that lateral area plus the area of the circle. So we're going to say, oh, I'll say it this way now just to be prettier. 3 pi square root 119 plus area of the base, which is just pi r squared. And that would be 9 pi here. There's really, if you're going to make an exact answer, there's really not a better way to write this. Put that in the calculator. It may give you something slightly different, but I don't think it's really better. You could get a decimal for it if you really wanted to. I want to get done with this video in less than 15 minutes. Okay. Surface area, and this is the last one. Surface area of a cone is 90 pi. If the radius is 4, what the L is this? Okay, so we have a cone. These are kind of hard to draw with this tablet thing. We have a cone. The radius down here, this thing is radius of 4. They tell me surface area, which is all of this, is 90 pi. Okay, that's kind of weird because that's, okay, if you like, pi RL plus the area of the base, which is pi r squared. That's all supposed to add up to 90 pi. Well, let's fill in what we know. I know the radius is 4. Don't know what the L that is. I know this is pi, this is radius, so this is 4 squared. Okay, I'm almost all the way there. This is 4 pi L. This is 16 pi. I can subtract the 16 pi on both sides. This is all just algebra at this point. Whoops, there was a pi there. 90 pi minus 16 pi, that's 74 pi. Divide both sides by pi. Divide both sides by, I'll divide both sides by pi first. It's just 74 divided by 4, which is something I'll mess up if I, something I'll mess up if I don't do it this way. 74 divided by 4, that's 18.5, or you could also think of that as 37 halves. I count like 37 halves, you know, just to be. Or you can call it, what was it, 18.5? Yeah, 18.5, either one. That's fine. That's the whole worksheet, I guess. Okay, see you in class. If you wanted to play around with that video that showed you, the 3D shapes you can manipulate, that would be a really smart idea. Let me get you that link. All right, here's that link. Sorry you can't click on it, but it's not much different than the other one before. If you could find it from the pyramids one if you had that recently on your computer. Okay, great. I'll see you in class.